This video is on solving quadratic inequalities. This right here is an example of a quadratic inequality. It's an inequality, obviously, because it has a greater than sign. It is quadratic because of the x squared. If you solved plain old 2x plus 6 greater than 10 back in Algebra 1, this was a matter of just subtracting 6 from both sides, keep that greater than sign, divide both sides by 2, and you ended up with x greater than 2, and you knew how to graph that. Because that was greater than, that was automatically greater than. You cannot just assume that on these problems that you will get to keep that greater than sign for your solutions. It doesn't work that way. We have to pretend that this is actually an equation. So we're going to drop the inequality sign and put an equal sign there, and we're going to solve that equation. Then we're going to plot those solutions on a number line. Then we'll do test points to determine which intervals need to be shaded. Then we will write the solution in interval notation. Here's my inequality. I'm going to just pretend that this is an equal sign instead. If it's an equal sign, we know how to solve that. We're going to solve this by factoring. It factors as 2x plus 1 times x minus 3. Because this times this equals 0, we can set each of those equal to 0 and solve simple Algebra 1 stuff. We're going to take these two values and put them on the number line. Negative 1/2 would be to the left of 3. These two numbers have chopped the number line into 3 regions. One or more of these regions will get shaded in, and the way to decide what regions to shade is to do test points. And you're going to do it in this chart format. Notice this. Here's my line with the negative 1/2 and the 3, and these down here come from right there. 2x plus 1, that was one of my factors. X minus 3, that was my other factor. And then this is the product of the two. We are going to pick numbers that are in these particular regions. So we need to pick something to the left of negative 1/2, like negative 2, or negative 3, or negative 4. It doesn't matter. I'm just picking something to the left of negative 1/2. Don't panic thinking you have to do some big-time arithmetic, because you don't. All we're going to worry about are the signs. Put negative 2 in here. 2 times a negative is a negative, plus 1 will still be negative. Put a negative in here, a negative 2, take away 3 will still be negative. If we do a product of 2x plus 1 times x minus 3, in other words, a product of a negative times a negative, we get a positive. Follow the same process here. Pick a number between negative 1/2 and 3. I'm going to pick 0. Put 0 in right here. This is going to be a positive value. Put 0 in here. 0 minus 3 is a negative value. Do the product of these two. A positive times a negative is a negative. Pick a number to the right of 3, like 4. If you put 4 in here, you're looking at a positive value. Put 4 in here, you're still looking at a positive value, because 4 minus 3 is a positive 1. A positive times a positive is a positive. Now, what does this do for me? Go back to the original problem. The original problem wanted greater than. The values that are greater than 0 are your positive values. So I'm going to shade the regions that have a positive on them. This is positive. That means this region is going to get shaded. And this is a positive. This region is going to get shaded. The only other thing I have to decide on is what's going to happen right here at these two positions. Depending on the book that you use, you're either going to use an open circle. I could use an open circle on both of those because this is plain old greater. Or for the book we use, it is this open parenthesis. So that's our solution looking a little bit more neat. And we've got shaded down this way, shaded down this way, and I'm using the open parenthesis. I could have just as easily used the open circle like this. Now, how do we write the interval notation for this? This is everything less than negative 1/2. So that is the interval from negative infinity, because way down here is negative infinity, on up to negative 1/2. Infinity or negative infinity always gets the plain old parenthesis, the curved parentheses. Negative 1/2 gets the curved parenthesis, because that's what's on my graph. That's why we use the curved parenthesis on the graph. Union with the same kind of inequality down here. This is from 3 on down to positive infinity. So the interval begins at 3 with a curved parenthesis out to infinity with a curved parenthesis. So this is my solution set. This is the graph of my solution set. One other important thing to say before we go to another problem is this. Note that the equation is in descending order and it's on the left side with 0 on the right side. That's what you want. If the original problem is not written this way, you're going to have to rewrite it. So you want descending order, and you want 0 on the right side. Another one. Here was the original inequality. Here is the equation that we're going to solve. Factor that up, set them equal to 0, and solve. So those are the two numbers that I'm going to place on my number line. I've already drawn the chart. Here are my three things: x plus 9, x minus 1, and the product of the two. And now it's a matter of doing your test. Something to the left of negative 9 would be like negative 10. Negative 10 plus 9 would be a negative value. Negative 10 minus 1 is a negative value. A negative times a negative is a positive. Pick something between negative 9 and 1. I get to pick 0 again. I like to pick 0 because the arithmetic's easy. 0 plus 9 is 9, which is a positive value. 0 minus 1 is negative 1, which is a negative value. A positive times a negative is a negative. Pick something to the right of 1, like 2. 2 plus 9 is 11, which is positive. 2 minus 1 is 1, which is positive. A positive times a positive is a positive. This says greater than. The values that are greater than 0 are our positive values. Since we're looking for positive values, we look down at the bottom line. That's all you want to look at is the bottom line. That positive right there tells me that I want this region to be shaded. That one's positive, tells me this is the region I want shaded. Because this was plain old greater, I'm using the curved parenthesis, or for you guys that like it, the open circle instead of the curved parenthesis, which then gives me this interval notation. All of this down here heading off into negative infinity land. So this is negative infinity to negative 9, union with 1 out to positive infinity. All right, next problem. Pretend that that is equal to 0. Factor and solve. This factors is x minus 2 times x minus 1. Set each one equal to 0 and solve. So here's the numbers I want to put on my number line, including with the chart. There's our 1, there's our 2. And of course, x minus 2 is right there, x minus 1 is there, and there's the product. So now is a matter of me picking the numbers I want to do the test. Something to the left of 1, I could pick 0 here. 0 minus 2 is negative 2, which is a negative. 0 minus 1 is a negative 1, which is negative. A negative times a negative is a positive. Now to pick something between 1 and 2, I'm going to have to pick a fraction or a decimal. I prefer a decimal, so I'll pick 1.5. 1.5 minus 2 is a negative 0.5. 1.5 minus 1 is a positive 0.5. A negative times a positive is a negative. Pick something to the right of 2, like 3. 3 minus 2 is 1, which is positive. 3 minus 1 is 2, which is positive. A positive times a positive is a positive. Now on this one, we are looking for less than or equal to. Less than would be our negative values. Where my bottom row has a negative is right in here. The other thing that's a little different on this is the fact that this is less than or equal to, so I'm going to be using my square brackets here. For you guys whose books use the open circle and closed circle, you're going to have that graphed. And I've already written out what the interval notation is on this one. Because these are square brackets, I have square brackets here, and this is from 1 to 2. We will do a couple more examples in the next video, which will be solving quadratic inequalities part 2.